So how in the world does a computer, a machine that literally just thinks in ones and zeros, make any sense of human language? With all its messiness, its beauty, its contradictions? Well, that's the giant puzzle we're going to try and piece together today. Let's get right into it. Yeah, that's really the fundamental question, isn't it? And to really wrap our heads around just how big of a challenge this is, let's take a look at a sentence that, to us, seems totally straightforward. So, when you read that, who's got the telescope? Am I the one using it to look at the man, or is the man himself holding it? See, for us, our brain sorts that out almost instantly. We use a whole lifetime of context to figure it out. But for a computer, that's a huge, huge problem. It just doesn't have that built-in context. And that right there, that's the absolute core of the problem. A machine looks at a word like, say, bank, and it has no idea if we're talking about a place to put your money or the side of a river. This idea of ambiguity, of words having multiple meanings, is the central challenge that an entire, fascinating field of AI was created to tackle. And that's where natural language processing, or NLP, as you'll hear it called, comes into the picture. It's kind of like the secret sauce, the magic that lets computers go beyond just reading our words to actually understanding them. Think of it as the ultimate bridge connecting our messy human communication to the cold, hard logic of a machine. It takes all our chatter and turns it into structured data that a computer can finally work with. All right, so here's our game plan. First, we're going to peel back the layers of language itself. Then we'll take a tour of the NLP assembly line to see how it all gets processed. After that, we'll look at where this tech is already popping up in your daily life. And finally, we'll peek into the future and see what big hurdles are still left to overcome. Okay, so if you want to teach a machine our language, you got to start with the basics, right? You have to give it a blueprint. And it turns out language is built on some really distinct layers. So let's think about language like a 5-layer cake, seriously. At the very bottom, the foundation, you've got phonology. That's just the sounds we make. Kite and night sound the same. The next layer up is morphology. That's all about how we build words from smaller bits, like sticking un and ness onto happy to get unhappiness. Then you've got syntax, which is just a fancy word for grammar, the rules that tell us the cat chased the dog means something totally different from the dog chased the cat. Above that is semantics, the literal dictionary definition of words. Is light the opposite of dark or the opposite of heavy? And then the icing on the cake is pragmatics. This is all about context. It's how we know that when someone says, "Can you pass the salt?" they aren't actually questioning your ability to lift a salt shaker, they're asking you to pass it. For any NLP system to be truly smart, it has to get a handle on all 5 of these layers. Okay, so we've got these 5 layers of language. How on earth do we get a machine to process all that complexity? Well, we build a factory. No, really. Think of it like a digital assembly line that takes in all this raw, messy human text and, step by step, refines it into clean, structured data a computer can understand. And in the biz, we call this the NLP pipeline. Let's walk down this assembly line. It starts with data acquisition, basically just grabbing all the raw text you can find. Think articles, tweets, customer reviews, whatever. Next is data cleaning, where you get rid of all the junk, like HTML tags or ads. Then comes text preprocessing, where we start to standardize everything. We'll talk more about that in a sec. And then here's where the real magic happens, feature extraction. This is the part that actually turns words into numbers. I mean actual numbers that a computer can crunch. From there, you use those numbers to build a model, an algorithm that looks for patterns. And finally, you test the heck out of it and then deploy it out into the world to do its thing. All right, let's zoom in a bit on that third step, text preprocessing. This stage is absolutely crucial because it's where we take that messy text and really start whipping it into shape for the machine. The very first thing we do here is something called tokenization. It sounds complicated, but it's not. It's literally just the act of chopping up a sentence into its individual words or pieces. We call those pieces tokens. So NLP is fascinating becomes 3 separate tokens. NLP, is, and fascinating. Simple as that. This gives the machine its basic building block. After we have our tokens, we usually want to simplify them, and this is where you face a classic trade-off between speed and accuracy. You have 2 main tools. First, there's stemming. Think of stemming as being kind of brutish. It just crudely chops off the ends of words based on a set of rules. It's super fast, but you might get weird results, like the word studies becomes studi, which isn't a real word. On the other hand, you have lemmatization. This method is much smarter. It's like having a dictionary. It looks up the word and finds its actual root. It's lemma. So studies correctly become study. Now, it's a bit slower, but it's way more accurate. So you can see the trade-off, right? If you're a giant search engine and need speed, you might use stemming. But if you're building a chatbot that needs to understand a user perfectly, you're probably going to lean towards lemmatization. Okay, so we've been deep in the weeds of this NLP assembly line, right? We've seen how the sausage gets made. But what does this factory actually produce? What's the end product? Well, the answer is all around you. It's the hidden magic powering so much of the technology you use every single day, probably without even realizing it. Think about your search bar. When you type in something like nearest pharmacy open now, the search engine isn't just looking for web pages with those exact 4 words. No way. It's using NLP to understand what you actually mean. It gets your intent, that you need a certain kind of business, that nearest means location is important, and open now means time is a factor. It understands the question behind your words. Or how about your voice assistant, Siri, Alexa, Google Assistant? They are basically a 3-part NLP symphony happening in real time. First, something called automatic speech recognition, ASR, turns your spoken words into text. Then, natural language understanding, NLU, kicks in to figure out the meaning and intent of that text. And finally, natural language generation, NLG, crafts a coherent answer and speaks it back to you. That entire process, listen, understand, respond, happens in like the blink of an eye. It's incredible. And let's talk about global communication. Modern translation tools are another absolute marvel of NLP. It used to be that they would just do a clunky word-for-word swap from a dictionary, but not anymore. Now, systems like Google Translate actually analyze the deep grammatical structure and the meaning of a sentence in one language, and then they figure out how to best reconstruct that same meaning fluently in the target language. It's why translation sounds so much more human and less robotic these days. But it's not all just about convenience. Here's an application that you might not see every day, but it's profoundly important: healthcare. Think about all the notes doctors write. They're unstructured, full of jargon. Well, NLP is now being used to read millions of these notes in clinical reports, automatically pulling out key information like symptoms, diagnoses, and medications. This is a game changer. It helps researchers spot public health trends, helps hospitals make smarter decisions, and quite literally helps save lives. So it's pretty clear that NLP is incredibly powerful, and it's already woven into the fabric of our lives. But, and this is a big but, it is far from being a solved problem. The smartest people in this field are still wrestling with some really, really tough challenges. To understand the challenges, it helps to know where we've been. In the early days, NLP was all rule-based. That means human experts would sit down and painstakingly write out thousands of grammatical rules by hand. It was super transparent. You could see exactly why the machine made a choice. But it was also incredibly brittle. It would break if it saw something new. Today, we've swung in the other direction. We use statistical models that learn patterns by digesting just massive, massive amounts of data. These are way more powerful and adaptable, but they can be a black box. Sometimes we don't know exactly how they arrived at an answer. And the toughest puzzles are still out there. I mean, think about it. How do you teach a machine to understand sarcasm? How does it know that when you say, "Oh, that's just great," you might mean the exact opposite? Or that "break a leg" is actually a good thing to say to an actor? That's all figurative language, and it's incredibly hard for machines. Then there's the problem of resource scarcity. Most of these amazing models are trained on English data. What about the thousands of other languages in the world that don't have these huge data sets? These are the massive questions that are really driving the future of NLP research. And when you boil it all down, the ultimate goal here, it's not really just about processing words anymore. It's about understanding the world behind the words. The real final frontier for NLP is somehow giving these machines what we all take for granted: common sense. That vast, unspoken knowledge about how the world works that we use in every single conversation without even thinking about it. Which kind of leaves us with one last big, fascinating question to chew on. We're spending all this time and energy building machines to understand and speak our most uniquely human creation, our language. If we actually truly succeed, what do you think they'll have to say?